Hi, this is Ralph Lemmel, and I want to present our industry track paper on the work item prediction challenge. This is joint work with Alvin Kerber and Liana Praza, work that we carried out at Facebook. The context of this paper is developer workflow analysis, and more broadly, you could say process mining. Okay, so what is the work item prediction challenge, and why is work item prediction challenging? Work item prediction is about predicting what a developer, or more generally an engineer, is working on. So for example, we might want to know what diff, that is what system change an engineer is working on. And it's challenging because we may not easily understand each action on the timeline of a developer. So when the developer publishes a diff or maybe reviews a diff, yeah, then it's obvious that the person is working on this or that diff. But when the person instead queries some database or reads some documentation, then it's not so clear what diff this could be about. And this is what we call dark matter. And there's also kind of in-between situations, like when the developer commits a version locally, and there's maybe not even yet the diff out there, then while we might need to make some effort to figure out. But the really complicated situations are those like querying a database or reading documentation, where we don't have any obvious heuristic to figure out what diff the developer may be working on. Okay, so here are two scenarios for work item prediction, just to show that we want to predict work items quite many times. So the first scenario would be incident response. So the work item of interest is some alert. And so the engineer would like to respond to the alert and would like to benefit from past responses. So we need some form of documentation, and it better be automatic because otherwise it's outdated. But how can we record the steps someone is putting into response unless we know exactly when the person is responding as opposed to carrying out some other work? Likewise, the aggregate performance scenario, or you might also think of what's called key performance indicators. Let's say you want to aggregate time spent on diffs over the entire organization, maybe use appropriate buckets to understand whether time spent on diffs goes up or goes down. So we would need to record all the activities going into diffs. And again, for some of the activities, it may be easier, but there's enough activities for which we wouldn't know easily to what diff or whether they are at all contributing to any diff. So here's one reason why it's actually challenging to predict work items. This is the situation at Facebook. So these are basically all our engineers here, many thousands. And these are all the tools used on a given day by those engineers. And you see like even half of them use around 100 tools or more. And obviously this tail here, this is probably about people not working full-time on that day. But you see there's enough engineers who even end up using like 1,000 tools, right? So these tools come and go, they evolve, they are not integrated, they don't have perfect logging. So we don't easily know what of these tools in what situations imply work on what sort of work item. So here's another reason why work item prediction is challenging. So this is the timeline of some developer. This is a small number of days. And vertically, we have the different diffs, that is system changes the person is working on. And so, for example, here we start a diff, like it's published, it's put up for review, or here we close a diff, like it's landed, it goes into production, or here we abandon diffs, and there's review events, and there's new version events. So as you can see easily from this, the developers working on these diffs in parallel, They might be more or less related, and we don't really know what's going on with these diffs here, because in this timeline we only have the activities that are most obviously directly related to specific diffs. We don't have all the other activities here for which we don't know how to associate them with those many diffs. Okay, so at Facebook we've done work on diff prediction to address some scenarios like those mentioned before, like measuring time spent on diff. And here's just a very basic layout of the architecture of the system. So it starts from a logging foundation where we basically integrate all available logs. As I said, these logs are not perfect, but nevertheless, we can integrate them to some extent, and we can clean them up, we can abstract them to some extent. Then we use the assumption that we operate on time windows of a developer. So we pick, let's say, 10 minutes as the granularity for which we want to predict the probability of an employee to work on a specific diff. Then what we have to do is we have to figure out what work items could the person possibly work on. For this, we take these high confidence events, such as someone is publishing a diff or reviewing diff, and we aggregate them over several days before and after the day of prediction. And so these are then all the candidates that we need to probabilistically rank. So this ranking, this prediction, is basically a composition of a bunch of heuristics and ML models. And again, so we use like high confidence heuristics, like someone submitted a diff revision, versus low confidence, someone queried a table that is also mentioned in a diff. Okay, so just one example of a particular ML model here. So remember, we have lots of internal tools, and most of these tools are web-based. So basically, we can look at all the UIs for tool usage. And then what we do is we basically extract words from these UIs, and we try to learn correlation or co-occurrence of words with diff IDs. So diff IDs have a very specific structure. They start with a D and then some digits. So we try to see what words co-occur with diff IDs. We extract all kinds of features about such co-occurrence, but the basic assumption is, let's say, if some word, like let's say this task ID here, occurred together with the diff ID several times, then maybe we can also conclude, I mean, the model can learn that the task ID just by itself may also imply the diff ID. Some lessons learned from this work on work item prediction. I will not go into any detail here. So the lessons learned basically concern the way how we use event logs, how we have to implement such a system as a non-trivial direct cyclic graph of pipelines. There are issues around validation. I mean, we need to rely a lot on internal validation because it's really hard to get enough human-based validation. This is pretty much all I wanted to say for this intro on work item prediction. So please see the paper for a detailed formulation of the challenge and also some details about the system that I only sketched here. There's also a detailed discussion of related work in the paper. For example, it discusses process mining and the related notion of case ID recovery, which we essentially need to solve here in a specific way for work item prediction. There's also a keynote at the same conference where I also get into this subject in some different way. Thank you.